Hello students. Last class we studied the vertical asymptotes of rational functions. Today we're going to look at the end behavior of rational functions, which can include horizontal asymptotes, slant asymptotes, or no asymptotes at all. Now the main thing that the end behavior depends on is going to be the degree of the polynomials in the numerator and the denominator. So let's consider a rational function, we'll call it r of x, and it's expressed as a quotient of two polynomials, p of x over q of x. So let's let this be a rational function. We're going to look at several different cases, and all of these are going to be based on the degrees of the polynomials. So first of all, the first case, if the degree of p, the degree of the numerator, is less than the degree of q, the denominator, then r has a horizontal asymptote at y equals 0. So if the degree of the numerator is less than the degree of the denominator, then the function will have a horizontal asymptote at y equals 0, which is the x-axis. And the second situation, we're going to look at two of these together. If the degree of the numerator p is equal to the degree of the denominator q, then r has a horizontal asymptote at y equals a sub n over b sub n, where a sub n is the leading coefficient of the numerator and b sub n is the leading coefficient of the denominator. We're going to look at two quick examples that demonstrate these, and then we're going to move on to slant asymptotes in the next video. Let's consider f of x equals 2 over x squared minus 3x plus 2. We already know how to find the vertical asymptotes, how to find the x and y intercepts. I don't want to talk about that right now. I just want to focus on the end behavior. Now, if we look at the degrees of the numerator and the denominator, the numerator has degree 0 because it's a constant, and the denominator has degree 2. So in this case, the degree of the numerator is less than the degree of the denominator, so we're told that there is a horizontal asymptote at y equals 0. So we've got a horizontal asymptote at y equals 0. Let me explain why this is the case. Horizontal asymptotes are asking us what's happening to the graph as x goes to infinity or negative infinity. We're looking at what happens when x gets really big in the positive direction or the negative direction. If we were to look at the function values here, as x goes towards infinity, as x gets really, really, really large, the numerator is always going to be 2. But the denominator, as x gets bigger and bigger and bigger, is going to get very, very large very quickly. Because, let's say x is 100, 100 squared is very, very large. And even though we're subtracting 3 times 100, the x squared term is always going to be bigger than the x term when we're looking at large values of x. In general, the leading term is going to be dominating the whole expression when we're looking at very large values of x, either in the positive or the negative direction. So what's going to happen here is the numerator is going to stay 2, but the denominator is going to get bigger and bigger and bigger and bigger and bigger. And when we take 2 and we're dividing it by 1,000, by 10,000, by 100,000, by 1,000,000, the denominator is getting bigger and bigger and bigger and bigger, which means the fraction is getting smaller and smaller and smaller and smaller, closer and closer to 0 as x gets bigger. So this tells us that the function f is going to be approaching 0. F approaches 0 as x approaches infinity. And the same thing is going to be true in the opposite direction as x approaches negative infinity. Because even if you take a large negative number, like negative 100 or negative 1,000, and square it, we're getting something huge down here, bigger and bigger and bigger. And so the denominator is getting bigger. That means the function value is getting smaller, and it's approaching 0 as x approaches negative infinity. So that's an explanation of why we have a horizontal asymptote at y equals 0 when the degree of the numerator is smaller than the degree of the denominator. It's because the denominator is going to be growing much, much more quickly than the numerator, so the fraction is going to get smaller and smaller. Now let's look at another example. Let's consider g of x equals 3x squared minus 12x plus 9 over x squared minus 6x plus 8. In this case, the degree of the numerator is 2, and the degree of the denominator is also 2, so we're in the situation where the degrees are equal to each other. This tells us that we do still have a horizontal asymptote, but it's given by the equation y equals a sub n over b sub n. So we still have a horizontal asymptote, but the y value is going to be given by the ratio of the leading coefficients. So here the leading coefficients are 3 and 1, and 3 divided by 1 is just 3. So here we have a horizontal asymptote at y equals 3. Now, why does this happen? The reason is when we look at a polynomial, either one of these, and we look at very large values of x, either in the positive direction or the negative direction, the leading term is going to be much, much larger than the subsequent terms. So really, the behavior is all based on what's happening on the leading terms. So here we look at 3x squared, and we've got x squared. The ratio here, 3x squared over x squared, is always going to be 3. Now, these other terms will contribute some value to this overall fraction, but the biggest and most important terms are always going to be having a ratio of 3 to 1. So what happens is, as x gets bigger and bigger, this ratio stays the same, and the extra little bits get smaller and smaller in comparison to these terms. So our function value is going to be getting closer and closer to 3 as we approach positive infinity and negative infinity. If you want to test this out, you can make a table of values, picking large numbers for x, like 100, 1,000, 10,000, or negative 100, negative 1,000, negative 10,000, and you should be able to see numerically that the function values are getting closer and closer to 3. So in this case, g approaches 3 as x approaches infinity, and also g approaches 3 as x approaches negative infinity. So these are the two situations where we'll end up with a horizontal asymptote. In the next 2 videos, we'll look at situations that give us slant asymptotes, which are diagonal, and then situations where the end behavior doesn't contain any asymptotes at all.